Today, we are going to study about the buoyancy. There is a particular name where we can't forget when it comes to buoyancy. It is great Archimedes, who was born in Sicily. He found out that when a body is placed in a fluid, it experiences an upward force which is equal the weight of the fluid displaced. This force is called the buoyancy force. Buoyancy force is a pressure force. Let's consider a sphere in a liquid. We'll have a horizontal plane cut ABCD as shown in the figure. The horizontal forces acting on this sphere are balanced to each other as they are 360 directional distributed. However, the vertical plane has a resultant force upwards. This is called the buoyancy force. You can find out the calculation of this buoyant force from this section. Please follow the 81 and 82 slides. The vertical force acts through the volumetric center of the displaced volume, and it is called the center of buoyancy. Now let us move to the most important section which we are going to discuss. It is the equilibrium of submerged bodies. We can have two types of objects depending on the amount of submergence. The first is partially submerged, the second is the fully submerged. Let us first look at the fully submerged case. We can have three stability conditions. The first is the stable stability, second is the unstable stability, and the third is the neutral stability. I'm sure you can remember these stabilities with solids which you have learned in your high schools. Now we are going to find the limits for these three states. When the object is fully submerged, the limitations are governed by the center of gravity and center of buoyancy. Let us give a clockwise tilt to the fully submerged object. Case 1. When the center of gravity is below the center of buoyancy, an anticlockwise moment is generated due to the upthrust, and that brings a righting couple to bring back the tilted object into original position. This is called the stable equilibrium. Case 2. When the center of gravity is above the center of buoyancy, a clockwise moment is generated due to the upthrust, and that brings a clockwise couple to the object. Thus, the object rotates in the unstable direction and it would not come back to its original position. This is called the instability or unstable. Case 3. When the center of gravity is coincided with the center of buoyancy, there is no moment due to the upthrust, Therefore, the object stays as it is at the new position. We call this the neutral equilibrium. When we look at the practical examples, a submarine and the stability of submarine is very important, and we consider these limitations for the stability. We always want to have the 100% accuracy in the stability, especially when we are under the water for 1000 to 2000 meters. Now the case is slightly complex when it comes to partially submerged case. In this case, the center of buoyancy changes its position from one rotational angle to another. Therefore, the analysis is slightly complex. However, we introduced a new theory for this, and it is called the meta center. The meta center is the point at which the line of action of the upthrust cuts the original vertical through the center of gravity of the body. Please refer the figure. Now let us look at the limitations for the three cases. If M lies above G, a righting moment is produced so that the stable equilibrium is satisfied. Case 2. If M lies below G, an overturning moment is generated due to the upthrust, and therefore the object fails stability and thus called the unstable situation. If M coincides with G, there is no moment. Therefore, this is called the neutral equilibrium. Please draw these cases and understand the moment direction. Now, what is metacent height? Gm is the distance between the center of gravity and the metacenter, which is called the metacentric height. How do we find this distance? Please try to solve the geometry and obtain Bm, that is the distance between center of buoyancy and the metacenter, is equal to second moment of area divided by the volume. Now this I, second moment of area, is the second moment of area of the floating surface. Volume is the sinked volume. Next time, we'll be looking at the motion of fluid particles and streams.